computer. With that talk by General McRaven, Admiral McRaven, very inspirational. I'll share the link for those who want to finish the entire talk. It's very, very inspirational. You could listen to it at your spare time. We jump into the scientific session of today's talk. We have Dr. Momodu, who's trying to demystify clinical research and statistical terms. Every day I pick up my journal or I'm computing my research data, or I'm pulling my research table, and I come across this lot of terms. I'm going to share it. And I come across lots of terms: T squared, P squared, T value, Z score, mean, median, mode. Our mission for these 2, 3, 4 sessions is to demystify it so that when you're reading those journal clubs, when you're in those journal clubs and you're reading those journals, or when you're trying to create a study, or when you're trying to analyze a study, you can understand what type of statistical terminology am I going to apply to this study to make it make common sense to everybody. Dr. Momodu graduated from Primary University. He's originally from Nigeria, now in the United States. He is very interested in family medicine and wants to be a family physician as his life goal. He's a lover of Christ. He told me that specifically, something I want to mention, and I'm very proud he said it. Should let the world know that he's a lover of Christ. Real simple things that get him going is looking for how to help people. And that's how he volunteered to give this talk. Dr. Momodu, walk us down the lane of statistics. Like, where do we start from?
I think for me, I'll start with like foundations, like understanding you have the mean, median, and mode. You have the range, variance, and standard deviation, and they're all grouped into like measures of central tendency and measures of dispersion. And I'll explain why they're grouped that way and what they mean and what their significance is with relation to research. Why are they important? Why do we use them? Why do we need them at all? Because I know that a lot of us grew up saying, oh, well, we're doing a lot of math, but what do we need it for? And all of that. So we'll see why we need them, especially in research. And then with understanding those foundations, we can then understand what the Z-score is, what T-score is, what all those like p-values, significance, because those are like the foundations for understanding those things. And so that's pretty much like where we're going to start. I think you're muted.
So let's jump at it. What is the very first thing a newbie, let's say I just graduated from med school, or I just went into med school, or I'm a French doctor who never paid attention to research, or I'm a professor who currently now trying to look for how to get papers. And then what is the very first thing that I need to, what is the very first statistical terms that jumps on me, or the common statistical terms, and what do they mean?
First of all, I'll start by talking about why we need statistics in the first place, like the importance of statistics, biostatistics, and epidemiology in the first place. Why is it important?
Absolutely.
It's important because, especially as doctors, we have all this, it's where we get our statistics from. If you see, especially most of our questions, it will tell you, it will give you the like maybe a clinical vignette, right? And it tells you, oh, this person is so age, this person is from this country, this person is this race, this person is this gender, right? And then it starts associating diseases with these people. Maybe Black people tend to have this disease more than these people. African-American people tend to have more of, let's say you have hypertension more than this, or maybe men tend to have hypertension more than women, or women tend to have maybe rheumatoid arthritis more than men. The way they got all of that data is through statistics. It's through statistics that we understand all of that. And so that is the first idea of understanding why it's important. We understand all of that through the statistics, the epidemiology that is done to see, okay, We take this number of people, we do a research on them, and then based on what we find, we can make all these values. We can collate all these results and then give you an interpretation of what they mean. And that's what these statistical values stand for. That's what they mean. That's why they are important, because they are good for interpreting where we are with regards to gender, with regard to age, with regard to race, and how they relate to certain diseases, to certain lifespans, and all of that. That's the main reason why we do statistics and epidemiology. And so now, speaking of that, going into things like measures of central tendency and measures of dispersion, I'm going to quickly share my screen to show you, just to give you.
So if I may piggyback on what you just said, the differences from the research or from the data usually explained better with the statistical, statistical points. That's what you're trying to say.
Yes.
Absolutely. Absolutely. Brilliant.
Okay, give me 1 minute. Let me see if I can.
This is IMG Research Academy, and in IMG Research Academy, we dedicate our time to understanding basic statistics, basic research, everything about clinical research. Today, we're discussing understanding basic statistics, what you see commonly, or what you're going to encounter when you're trying to design your studies, what they mean, how you use them, when you use them, what you use them for. And today we have Dr. Momodu, who's making a lot of attempts to demystify these concepts. Statistics will take you close to a number of years to understand, but we'll do our best to see what we can discuss within this next 30 minutes. Over to you, Momodu.
Okay, so can everyone see my screen?
Sure, I can see your screen.
All right. So now we come to the idea of like the mean, median, and mode. These are things that we've heard over and over. We come to standard deviation, standard error. We have things like variance. I don't know if you can see my cursor.
Absolutely.
Okay, we have things like variance that are also measures of dispersion. We have things like range and all of that. Those are measures of dispersion as well. But the three measures of central tendency are mean, median, and mode. Now, the first thing I'll try to explain is what is central tendency, what is dispersion, what are the differences. So this is important because for central tendency is, they're trying to tell you we're trying to get to the center of something, right? We're trying to get to the center of something. So we're trying to find out something that is in the center. So you have things like mean, which is kind of like the average. So for example, I want to know, I live, maybe like right now I live in Indiana, right? I want to have an idea, what is the average temperature that I'm likely to expect on a given day? You understand, maybe within the summer, right? And so I take a number of temperatures and I divide that number. I do the sum of those temperatures. Maybe I have 5 values of temperatures. I want to know what's the average temperature I'm likely to encounter on a summer day in Indiana, right? So I take the average of those temperatures, I divide by the number of those values, which is, I have maybe 32 degrees, 33 degrees, 34 degrees on another day, 35 degrees on another day, 36 degrees on another day, right? I take the average of those values and divide by the number of values, then I get an average temperature. So let's say I get something in the middle, right? I say I get 34 degrees. That tells me that the likelihood, the most likely temperature I'm likely to experience is around 34 degrees on a given day, on a given summer day in Indiana. That is what, so it's giving me the middle number, the central number. That is the idea of central tendency. Yes, the most common thing, the most likely out of all those values. I want to know, I don't want to be so confused about what to get. I want to get something, the most likely thing. that is what the central tendency is
Let's,
about.
let's use a real life scenario.
Okay, so for example, I say I have blood pressures of, let's say, 5 Black people, and I have blood pressures of 5 white people, right? I want to know in a particular area. Let's say I live in, I feel most of us are from, I don't know if most of us are from Nigeria or most of us are from the US, but let's say let's use the US, right? I mean, we're here. So let's say in Indiana, we have the city, Illinois, we have Chicago right now. And then in Chicago, we have downtown. And I want to know, in downtown, I take 5 Black people's blood pressures on a given day, and I take 5 white people's blood pressure. I want to know what's the average blood pressure I will find in those Black people compared to the white people, right? And so I get maybe for one person, I get 130 over 80, another person I get 120 over 80, another person I get 110 over 80, another person I get let's say 140 over 80. So, and maybe the last person I get 150 over 80. So you have 110, 120, 130, 140, and 150. Now, when you do the average of that, it will be the middle number, right? Which is about like 130 over 80. So I know that if I go to downtown Chicago on a given day, there's a high likelihood that if I can make a guess that what is very likely the blood pressure I'm going to find in this person, and I would say, okay, the high likelihood is that the most common one will probably be 130 over 80. If I'm just looking for one number, right?
Brilliant.
Now that's dealing with the mean. The median is pretty much the same idea. I take all of that and then I arrange them in order, and I want to find the middle number, because like I have a lot of values here, I have a lot of values here, but which one really falls in the middle? That's the idea of the median. Right. Which one really falls in the middle? What's the likelihood? So that is another measure of central tendency. I want to know what's the middle number, what's the most likely value I'm likely to expect. So it kind of focuses things for me, which is why it's called a central tendency. What's the central tendency of that measure that I'm likely to get? You understand? That is the mean, the median, and same thing with the mode. What's the most common value? That's what it's saying too. The most common value. So that's a measure of central tendency. Now where the measure of dispersion comes is this. I might know what the measure of central tendency is, but now I want to know what is the distribution, because that central tendency doesn't really tell the whole story. It tells what's the most likely, but it doesn't tell me how is it distributed. So I might have one value that's very high, and I might have another value that's very low. And maybe I might have maybe 2 values that are low, but I have one value that's very high. And that value that's very high is very likely to pull up the average, right, to a particular number. But I want to know, okay, what is the actual dispersion? How is it actually distributed? I want to know, okay, I don't just want to know what the most likely blood pressure, but I want to know how the blood pressure is actually distributed among the population. That's where the measure of dispersion comes. So now that's where you have the things like the range. So for example, the range tells you, I might have, and I'll use an example for this. I use two different values. Let's say I have one of maybe 0, or let's say minus 10, 10, minus 10, 0, 10, 20, and 30, okay? So you have those values. If you take the average of those 5 values, you get an average of 10, right? But then if you have another set of values, 8, 9, 10, 11, 12, if you take the average of those values, you will also get 10, right? You get the same measure of central tendency but it doesn't tell the whole story because the measure of dispersion is not the same. Because in the second one, you have only a difference of one value between each of them. You have 8, 9, 10, 11, and 12. The average is still 10, but then here you have -10, you have 0, you have 10, and 20, and 30. The distribution is wider, right? And that's where the range and the measures of dispersion come. So what the range will now do is it will take the highest number minus the lowest number. And so, for example, in the second set of values, you have the highest number is 12, the lowest number is 8. And the range between those values is just 4, right? But meanwhile, in the other set of values, even though it has the same measure of central tendency, the same average, you have the highest number is about 30 and the lowest number is about -10. When you do the range, the highest number minus the smallest number, it's about 40. The gap is wider. That tells you that the difference between those two measures, the difference between those two set of values is much different, right? And so you get a measure of dispersion, you get the measure of the distribution of this set of values. You see the differences between all of that. I don't know if it's clear.
Absolutely.
Does everybody?
Yeah, absolutely. Before we jump into the next set, I also, there's something as I was growing in statistics, I also learned that even when you're analyzing events, you can also use some of these statistical data points.
You must know it.
Oh, give me this.
I know. It's
Thank you. And you can also use this data points or these statistical references for ordinal or nominal data. For example, if you're analyzing events in a clinic and you want to analyze, let's say, severe cough or severe skin rash or type 1, grade 1 cancer to grade 4 cancer, and you're writing on all those things. Let's say the number of patients that come to you are like 50 and you're saying grade 4 melanoma or grade 2 melanoma, and then you're writing a paper, real life scenario, you can actually also do this. What we do in research is we then codify this this nominal variables. We codify them. It now makes it easy for us to now imply them or transfer them or relate them in statistical words. So if I could, let's say, for example, type 1 to grade 1 to grade 4, or type 1 to type 4, whichever you want to use, that's presenting more common. You could say, I'll codify type 1 as 1, I'll codify type 2 as 2, I'll codify type 3 as 3, I'll codify type 3 as 4. And then you now do, it now gives you, you're transferring them from their nominal value to the measurable value. So some people would say ordinal scale, which, you know, when we get there, we'll discuss it. So when you codify it, it now helps you to plug it into your calculators, because there are various softwares that will help you to do these calculations that you want a calculation. Dr. Momodu, let's move on to the next topic because of time.
All right.
What do we have to learn today?
So now the next thing, based on what we understand about like all those mean, central tendency, and dispersion, the next thing I want to explain is what like a sample mean and a population mean will be. So for example, you have a population mean will be, I have maybe a population of 100,000 people, right? And then I take the average of, let's say I'm trying to find out what's the average age of that population, right? And so I take the ages of everybody of the whole 100,000 people in that population and I add all their ages and divide by the number of people in the population, which is 100,000 people, right? And I get a particular mean. That is called the population mean, all right? Now, a sample mean is different in the sense that, okay, I have a particular a population of 100,000 people, but then maybe, for example, it's a bit too many a number for me to use. And then I decide I want to have an idea of what the mean will be if I just took a sample of those people in that population. So instead of using 100,000 people, I decide I want to take 100 people and try and guess and have an idea of what that mean will be. You understand? So now I take 100 people and then I do the average. I check out the number, their ages, add it up together and divide by that 100 people. Now I have a mean that is not the exact mean, which is in the population,
right,
but only in that sample, and it will give me an idea what that population mean will be. I'm trying to use that sample mean to get an idea of what that population mean will be. Now, obviously, you know that this could range. I could be right, I could be wrong, and that's where this issue of confidence interval comes in. All right. So
before you jump into confidence interval, I want to give a common example on most of the papers I've been writing, because if you have paid attention, we extract data from NIS or NIH or National NHAIS or wherever, CDC Wonder. And then we extract those data and we analyze them and we write our paper based on those data. Most of those data that we extract are sample data. They don't
cover the whole population.
They don't cover the entire population of the US. However, we make our, let me use the word guesstimation or estimation based on that data. That becomes our sample, and then we make our statement that, the mortality in depression is more, for example, in the white population or in the Black population compared to the Latino population, something like that. This comes into operation. You were trying to talk about variance. Take it from there.
Yeah. So now variance, range, and standard deviation, these are measures of dispersion that can be used to, I've already talked about range, and the same idea applies to variance and standard deviation. These are things that show us the distribution of values within the numbers that we are studying. All right. Now, I've talked about the sample mean, the difference between the sample mean and the population mean. Now, because that sample mean is not an exact reflection of the actual mean, this is now where a confidence interval comes in. All right. Because now I have to have a confidence interval shows me how confident am I? Yeah, how confident am I that this sample mean that I got is a true reflection. Is a true reflection of that population mean that is the actual mean. You understand?
Let me just chime in there, and that is why one of the reasons why we're doing this national inpatient studies, because national inpatient study is like 20% of the entire admission in the US. So we're working with like 20% of the entire admission in the US for the overall admission. One of the requirements that the journals require you to do whenever you're doing this national inpatient study is to do this confidence interval on your data. If they don't find a CI in your data, they're automatically going to reject it, because they want you to tell them how confident are you that this analysis that you've done based on 20% of the population is going to be extrapolated, or is going to be a reflection of the total population. Because at the end of the day, we're going to make a statement that is going to go out. Obesity is more in the Blacks than in the white, based on 20%. And then we're going to tell them, yes, based on this 20%, we're this amount of confidence, or we are this confident that this our statement is almost true. Go ahead from there, Dr.
All right.
I'm enjoying this conversation.
So now, for example, you have a standard deviation shows you, if you look at this here, right, it shows you 68% of people fall within a particular distribution of the population, and 95% of people fall within a particular distribution, 99.7% fall within a particular distribution. Now, all this -1 plus +1 -2 +2, that tells you how many standard deviations are from the middle, all right? So that tells you, okay, we have a particular value, and then away from that value, you have on both sides, you're one standard deviation away from the actual value, all right? So the standard deviation tells us what's the deviation from the standard. You understand? The standard is what it's supposed to be. The standard deviation is how far away from that standard is it. So now we know that one standard deviation away from the standard falls, 68% of people will fall within one standard deviation away. 95% of people will fall within 2 standard deviations away from the standard, all right? Now, what the confidence interval does is to show you, okay, now I have this, I'm going to say I'm 95% confident that a particular set of values, the confidence interval is a calculation to measure a range of values for the mean, for the sample mean that we get. You understand? So I decided to do a mean from the sample population, remember? But then we're not just getting one value, we're getting a range of values, which is why you see a plus or minus, right? So I have a particular mean that I get from a sample, but then related to that standard deviation, what that standard deviation does for me is to give me a range, not just one value. It gives me a range of values in which among those range of values, the true mean is likely to fall among those values. Do you understand? So now what the z-score and confidence interval is, okay, I would say that these z-scores have been calculated to correlate to certain confidence intervals. You understand? So for example, if I want to say I'm 95% sure, the related z-score for that 95% confidence interval is 1.96. So if I see a z-score of 1.96, what I'm saying is that I am 95% confident that the values of the mean, the range of values of the mean, the true mean will fall within those range of values that I got for the confidence interval. Do you understand? For the confidence interval of the means.
I think, Dr. Mamodu, because of time, we're going to spend a little time here, because this is, if we need to understand this before we step up to the next concept. And then we're also running out of time, but I don't want us to rush this because it's a series of, roundtable scientific sessions that we go on for about 4 sessions. Someone asked, Dr. Blessing, you're free to unmute your mic. We'll put you on the spotlight. We're going to open the conversation for everyone to chime in. Please, if you want to make a comment, keep your comment very brief, less than 30 seconds. If you want to ask a question, keep your questions also very brief. Unmute yourself, put your mics on, and then you can ask them. There's a question in the chat about standard deviation. Is it a reference to the mean, and what mean are you referencing?
Okay, yes. So the standard deviation is related to the mean, the population mean. So it's already calculated ahead of time, and it's based on, it might be a value that has been calculated based on something else. You understand? We have a mean of the population based on, and if you know how the standard deviation is calculated, it's calculated from the variance. I don't have time to really go into the calculation now, but or to the formula and all of that. But you have like a mean that you have gotten, and then you say, okay, among the values that I have, right? Among the actual values that I have, I take each value of among all those, let's say I have 5 blood pressures, right? I take and I get the mean of those 5 blood pressures, right? Now I want to know what's the standard deviation from that mean. And so I take, remember we are thinking about measures of dispersion now. How widely distributed are those values? You understand? That's the idea of this standard deviation and all of that. It's a standard deviation from the mean. And so I take each value, and then I compare to the mean, each one by one. You understand? This is how like those variance and standard deviation is calculated. I don't have time to get into it, but that's how it's calculated. I want to know the differences from that mean between each one. You understand? That is where the z-score comes in. It's used when you already have an idea of a standard deviation from the start. So you might not know, you have a standard deviation that has been calculated prior to coming to this particular study. You understand? You already have a standard deviation of a population prior to coming to a particular study, and then you come into this study a sample mean, right? And then you're trying to find out what's the likelihood that this range of values will fall within that mean. You understand? And that's where the standard deviation comes in. Now, the difference between a z-score and a t-score is this. In a z-score, you already have the standard deviation. In a t-score, you don't have a standard deviation.
Mm.
That's the difference between where you use a z-score and a t-score. So if I already have a standard deviation ahead of time, I already know that, okay, there is a particular deviation from the mean already, and then I can come with my sample mean to measure. Maybe before what was studied before was maybe they studied something related to blood, but now I'm coming with a new study. You understand? And maybe that study related to blood, they've already gotten a standard deviation from that with the same population. And then I want to do a different study on blood pressure, not blood now, but blood pressure. I can use that same standard deviation and apply it to my particular study, even though it's a different study, because I already have an idea of what that standard deviation is for that population. But now a t-score is used when we don't already know the standard deviation ahead of time. That's the difference. You understand? So now you're using this z-score. We now come back to the z-score, right? The z-score, you're using it based on, you want to know the confidence interval. I don't know if that answers the person's question.
Dr. Blessing, if you're here, you could either chat or talk. Did he address your question directly?
Yes, thank you so much, Doctor. Yeah, I'm good.
Okay. So now, these z-scores are calculated to relate to certain confidence intervals. So if I have, like you see, if I have a z-score of 1.96, it's telling me the confidence interval is 95%. If I have a z-score of 2.58, it's telling me the confidence interval is 99%. So what it's telling me is that from this sample mean that I took, now not the population mean, this sample mean I took, I'm confident that this set of values of the mean related to that sample. So out of that 100 people, the range of values, I am 95% confident that the actual population mean is going to fall within those range of values.
Right.
Now, if I see a z-score of 2.58, what that's telling me is that I am 99% confident that among those range of values, that I'm 99% confident that the real population mean of those 100,000 people will fall within this range of values of that 99%. But remember, the z-score is in relation to the fact that we already know what the standard deviation is. Now we use a t-score when we don't already know what that standard deviation was in the first place. You understand? And that's the idea of like those confidence interval and z-score, t-score, and sample mean, population mean, and all of that.
Brilliant. Dr. Mamadou, we're gonna put a break on this conversation and open the floor for everyone to chime in. We have about 10 minutes to wrap up for today because we want to respect people's time. Our program is usually 1 hour so that people could go and unwind. Happy Father's Day to all the fathers in the group, and the fathers that are yet to be in the group. Happy Father's Day to everybody. If you have any question, open your mic, ask your question. I see some questions coming in. We're going to take 2 or 3 or 4, and then we'll end the recorded scientific session, the recorded scientific session, and then go into the ordinary session where everybody's free to ask anything that they want to ask. So Dr. Ibilola said, please, I missed that. If Z-score, Dr. Ibilola, can you raise your mic and can you unmute your mic and then please explain what you're trying to say? And then Dr. Latif, is there a formula for Z-score? So what I usually tell people about formulas and non-formulas is that the world has gone real digital. Most of the things that we do in our IMG Academy, we just use softwares, just plug it into software. Strata, even Microsoft Excel can give you great calculations. There's so many software, just plug it in. You don't have to stress yourself about what the formula is. But Dr. Mamadou, if you can jump in, and Dr. Ibilola, unmute yourself, let's hear you talk.
Yeah, thank you so much for this opportunity, and thank you so much for your time, Dr. Mohammed and Dr. Edward. Yeah, my question is this. I missed it. You said it over and over again, but I just kept on missing it. I want to understand it very well. So if the you said if the Z-score it's like 95% or something, or maybe the Z-score is like a particular value, like maybe 2.5 or something, then that implies that the confidence interval is something.
Yes.
The value, I missed it. I want to get it. I know it's
So,
something subtracted from 100. Then, then it also implies that I am sure that something. Like I want to get the meaning and that.
Now the question is, did you understand the idea of the sample mean and the population mean?
Yes, I do.
Okay.
I do.
Okay. So now, if you understand that, and this will also relate to that question about is there a formula for the Z-score? All right. So, like Dr. Edward was saying, you already have like these things, they're plugged into their values. These are things that are calculated ahead of time. It's just like, for example, we have all these formulas in math, right? That we have already derived from, if you did further maths is where you find out how that particular equation was derived in the first place. You understand? Now, it's the same here with the Z-score. You already have all these things that are right now already like automatic. You do it like a particular data in the computer, it already comes out for you. So ahead of time, there is a formula for the Z-score, but I don't think it's something you need to know. So the idea is that they've already calculated ahead of time for you, and they've already let you know that a Z-score of 1.96 relates to a confidence interval of 95%. And then a Z-score of 2.58 relates to a confidence interval of 99%. All right, so that's why they'll tell you here that for the 95% confidence interval, the Z is 1.96, and for the 99% confidence interval, the Z is 2.58. So it's kind of like a fact that we already have now. So just keep it in your mind that if I ever see a Z-score, I'm ever given a Z-score of 1.96, what they're telling me is that the confidence interval is 95%. And if I ever see a Z-score of 2.58, what they're telling me is that the confidence interval is 99%. Is that understood up to this extent?
Yeah.
Especially with the people who asked the question. I don't know if that's understood up to this extent. Now,
yes, thank you.
Okay, now where the confidence interval for the other person who asked relates to the Z-score is this. The confidence interval relates to the sample mean. Remember that the sample mean is, I'm trying to gauge an idea of what the population mean is, right? I have only a sample that I took out of the whole population to make my studies. Now I want to find out what is the likelihood that the true that this sample mean that I got is a true reflection of the population mean, right? And so with the confidence interval is this equation right here, and the Z-score is plugged in. You understand? So now what that tells me is this, like I get a particular mean for the sample, right? And then with relation to the standard deviation that I have, I do the z-score and all of that, I get a range of values, because if you see, it is a mean plus or minus a number that you will get based on the z-score, right? I don't know if that's clear. Use this X with the stuff on top is the sample mean you got, but then the z-score relates to the confidence interval and will give you a plus or minus value. So let's say I do this, maybe the z-score I get is 1.96, right? And I get a standard error of a mean of a particular value. So let's say can you use confidence the standard deviation? Well, not necessarily. So the confidence, I just want you to understand that with the confidence interval, what it's doing is that it's giving us a range of values. Okay, it's not giving us just one value, it's giving us a range of values for that mean. All right, that's one of the main things it does, is give us a range. So I calculate a mean out of that sample, I get one value, right? So I have a population of 100,000 people, I get a mean, all right? That's the population mean. But now out of that 100,000 people, I don't want to use, maybe it's too large for me, I just want to take a subset. I take 100 people and then I calculate the mean from that 100 people. I get one value as well, all right? I get one value as well for the mean for those 100 people. But now I want to have a range for that mean that I got. I want to have not just one value, but I want to have a range where, let me say a range of safety, a safety range, a safety net that I can say, oh, because, you know, I get a sample mean of one thing, I'm likely to be wrong. You understand? I'm less, let me not say I'm likely to be wrong, I'm less likely to be correct. It's less likely to be an exact reflection of the population mean. But I want to get a safety net related to that sample mean that I got from only those 100 people. And so what I'll do is that this X here will be that sample mean, and then I'll have this z-score that I'll plug in and the standard error of the mean that I'll calculate, and it will give me a particular value. So let's say I do, let's say, let me plug in some values that will make it maybe a bit clearer. Let's say I get 100,000 people and the age of, I do an average age of those 100,000 people in that population. Let's say the average age I get in that population of 100,000 people is 55 years old, all right? That's the population mean age that I get. That is the most accurate age of that population, all right? But let's now say I take 100 people out of that population and I decide to do an average age of those 100 people. And let's say I get 52 as the average age. Now we know that the real population mean, the real average age is 55, but with this sample, I got 52. It's close, but it's not very accurate. All right. So now what I would do is that this X will be that 52 years old age that I get out of that sample. And then with the z-score, I will calculate, I'll get a particular number. Let's say I get 52 plus or minus 5. All right. So that tells me that you take 52 minus 5, that gives you 47. And then 52 plus 5, that gives me 57, right? So I now have a range. What it has done for me is to give me a range between 47 and 57, and not just that 52 that I got. Right. Do you understand? So now I now have a range of ages that serve as the mean, a range of mean ages between 47. So now the range of values of that mean of that sample is between 47 and 57. So it's not just 52 now. And now I can have a particular confidence that my actual age, which is 55, falls within those ages of 47 and 57. And it's not just 52. Do you understand? Now, where the whole Z-score now comes in is that it tells you that if I used 1.96 to calculate that range of ages to get those set of values between 47 and 57, it means that I'm 95% confident that that 55, that real population age, falls within that 47 to 57. Do you understand? But if I use 2.58 to calculate that range of 47 to 57, it tells me that I am 95% confident, sorry, I'm 99% confident that that actual average age of 55 falls within that 47 to 57. Do you understand it?
Brilliant. Dr. Momodu, there's a question in the group by Dr. Bright. I think he's asking if there's a difference in t-test and t-score. I'll just chime in that briefly.
Yeah, okay, go ahead.
For the session, the scientific session. They are both statistical concepts. T-tests sound similar. Tests and score, but we use tests to test for significance, and there are various types of statistical tests that we could use to check for significance. What do I mean by significance? What in this IMG Academy, we're trying to break these things down as simple as possible. So if I do a study, let's say I study two groups, I usually use the whites and the black, which is a very common thing that we common reference points. And I want to study how early dementia sets in white compared to black, right? And then I have age, let's say 70 in blacks and 75 in whites, or vice versa, whatever it is. These two numbers are numbers, or these two means, or let's say I'm trying to calculate a mean. These two are two different means. The question I'll ask myself is it earlier in whites or later based on these numbers? I look at the numbers 72 and 75. But the deeper question is a statistician or a scientist like both of us, like all of us, a medical doctor, we ask is it statistically significant? Is it this between 70 and 72, is this statistically significant? If I want to determine if it is statistically significant, then I'm going to use the tests for significance. One of those tests for significance is a t-test, comparing the mean of two groups. So if I have two groups, whites and blacks, the mean or at which age they have dementia or Alzheimer, one is 72, one is 74, for example. And I want to see, does it really matter? Is this significant, this difference that I have, let's say 71.1 and 71.8, then I will use a t-test. There are various other types of tests that we could use to determine significance in the various variables that we're trying to analyze. One of them is the p-value, the one that we commonly know, the ANOVA of variance, the chi-square. So we use this test to determine significance either between the sampled mean and a true population, or we're using it to determine between population A and population B, population A, B, C, D, E. Not only population A, B, C, D, E, we can also do what they call regression analysis between, okay, blacks, female, age, teenager. So in multiple layers, we want to do a regression analysis and see how statistically significant the various outcomes that we received or that we calculated in the various categories that we're trying to analyze, how they are. So these are t-tests, ANOVA, regression analysis, P, chi-square, and the rest. A t-score, Dr. Momodu has taken his time to explain, is just about the level of confidence or the variance between a mean of a data and an unknown mean that you're trying to get. With that statement, Dr. Mamadou, thank you so much. You can stop sharing your screen. We've come to the end of the scientific session for today. Dr. Mamadou took us through memory lane, what we used to know, the basics in high school medicine, high school life of medicine. And then we're trying to make it make sense in our everyday research activities. Thank you, Dr. Mamadou. Thank you, everyone, for tuning in. We're going to switch over to our ordinary session. My name is Edwards. I'm the director of this program. We'll be having the next scientific session in 2 weeks' time, same place. We're going to invite another eminent personality who's going to go beyond what we've discussed to the other components of common statistical terminologies. Thank you, everyone, for listening in, and then we're going to end the ordinary session. Thank you, Dr. Mamadou.
All right. Thank you for having me. I hope it was helpful.
It was beautiful.
All right.
And then we're going to post it on our YouTube channel. Please feel free to follow us on our YouTube channel as we end this session.